To better grasp the idea that beta hat is a random variable, we will perform a Monte-Carlo simulation in R. And we will understand better what are the characteristics of beta hat, what is its expected value, what is its standard deviation. So I will just show some R code in the video. You don't have to repeat this yourself, rather you will do a very similar analysis in the corresponding RTutor problem set. Here I have an empty R file, and I first repeat the simulation of our ice cream model. So I define some number of observations, some true coefficient, let's say beta 0 is equal to 100, beta 1, the slope of the demand function, shall be equal to -1. Then I draw some epsilons. I draw them from a normal distribution. I want to have t observations. The mean shall be equal to 0, and the standard deviation, or let's say it's 5. Maybe we change it later. Here we want to assume that the prices are just drawn completely independently from each other variables in a random fashion. So I use the function runif to draw uniformly distributed prices. I want to have t prices, and let's say the prices are between 20 and 50. We can also change this later. Now I want to compute the demand. I call it Q. It shall be equal to beta 0, the constant of the demand function, plus beta 1, the slope of the demand function, times the price, plus the demand shock, epsilon. And I can run everything, and here I see that I have generated the variables I like. Now let us also estimate our demand function with a simple linear regression. I use the command lm for linear model, and I type the formula that is simply the dependent variable q, this wiggle, it's called a tilde, and I just type the only explanatory variable, the p, and I run this line, and here I get my estimated coefficients. And you see they are pretty close to the true values. So this is a beta hat 0, intercept is our estimate for the constant, it's 99.6, and the true value is 100, and our estimate for the slope, the beta 1 hat, so that's the coefficient in front of the price p, it's minus 1.015, and the true value is -1. If we go back to our exercise sheet, we shall write an R function called sim&est that performs the simulation and returns the estimated coefficients of the demand function. And it shall have the sample size t as an argument. So let's do that. In order to just return the coefficients, I use the function coef, and I put it around my lm command. And let's run this line, and here we just get basically a vector of the coefficients. So it looks very similar to this, but the actual R object here is similar, easier, it's just a vector of numbers. It can have names, but that's what we get. And now we want to put this into a function. So I take all my code, and I write the function name sim and est. I write that it's equal to a function. First, I use a function without any argument. So I have two round braces, and then I have this curly brace. I open it up, and then I take all my code, I cut it, Ctrl X, and put it inside the function. And then I mark it again, and I press on tab to basically put it once to the right, so that's to make the function look nice. And that's my function. It's called sim&est. I mark everything and run it. And we see also now here in the global environment a function called sim&est. So here's not the whole name. And now I can call it. I can write sim&est, and I get a result. So what this function does, it simulates a random data set and then returns the OLS estimate of the demand function for this data set. If I call it again, I get different data set and I get a different realization of my estimator. Here I get a different number for the estimated constant and the estimated slope of the demand function. And I can call it again, and I again get some different numbers. We are not completely finished with our function because the task was to use this t, the sample size of the data we draw, that shall be an argument of the function. So I write it in this round squares there. I can give a default value, let's say by default t is equal to 100, and very important, I have to delete this assignment of t inside the function. I run this again, now I have the new function, and I cannot call sim and s with an argument. I can set t equal to 5.